Hello, and welcome to another episode of Physics Chat. Physics Chat is a show where we talk to real life scientists and ask them what it's like to be a modern day physicist. We talk about everything from their hobbies to how they are expanding our knowledge of modern day science. But you know I couldn't do this alone. Fox and Dan have joined me on the hosting panel. How are you doing, Dan?
I'm good, thanks. How are you?
I'm doing well, thanks. And what about you, Fox? Are you looking forward to today's guest?
Yes, of course.
Oh, so am I. And on today's show, we have the incredible Katherine Shirley, who is a postdoc at the University of Oxford. Hello, Katherine. How are you doing?
Hi, thanks. I'm well. Thanks for having me.
So could you tell me how you ended up in physics?
Right, so I am actually a geologist. All my degrees are in geology and planetary science. However, I use physics techniques in my work. So I made it here, and Oxford is really great because of the group that I'm in actually builds a lot of instrumentation that goes off into space. And I can use that then, these kinds of satellites basically, to look at the surface of other planets, figure out what those rocks are, and use my background to interpret them and figure out, how this planet may have been made. And that tells us a lot about the history of that planet.
Wow, that sounds so exciting. Could you actually give us some more examples of what you're actually researching now?
Sure. So I work on several different moon missions. These include Diviner, which has been in orbit around the moon since 2009. It looks at the surface of the moon, and I look at the temperature of the surface, as well as figuring out what the composition of the rocks are. And I'm also on this mission called Lunar Vise, which is going to launch in 2026. And it's actually going to land on the surface, and it's going to land on the top of a volcano, an extinct volcano that's on the moon. So that one is really exciting, and I can't wait for that to happen.
Those sounds really, really exciting. So on the moon, I've heard several theories on how the moon is formed. Is there a current consensus on these theories?
Well, right now, our leading theory is the impact theory. So this kind of means that at the beginning of our solar system, when we had all of these planetesimals and debris coming around, snowballing together and creating the objects we have today, there was this large Mars-sized object in the vicinity of our proto-Earth. So that crashed into Earth, and then we ended up coalescing a new Earth and moon in the same kind of system. So we have what we have today pretty much, except that the moon would have been much closer at this stage. And it's been slowly running away from the Earth, more or less. And it's still moving away today. It's just at a very, very slow rate.
If a much younger Dan was here today, he'd be asking you what kind of cheese is the moon made of. I used to love watching Wallace and Gromit when I was a little kid.
We do a lecture here actually that talks about how do we know if the moon is not made of cheese, and basically the experiments that we do are looking at temperature. So cheese is gonna melt, and we know the moon is super hot. It gets almost 200 degrees during the day, so it would definitely be melted if it was cheese.
Oh, amazing. Okay. That'd be great. You could just take some bread there and just scoop on it. Great.
Ooh.
Anyway, more seriously, as a grown-up, what kind of rock is the moon made of?
The moon is actually made of very similar rocks to what we have on Earth. It's all kind of the same building blocks. It's just presenting differently. So when you look at the moon at night, you can kind of see the main two terrains. So the bright, lighter patches are called the highlands. These are made of anorthosite. This is a type of rock that you can find on Earth. It's just much more rare. The dark patches that you see, kind of the face of the moon, basically, that is made of basalt, which you would probably recognize from seeing like fire fountaining videos of volcanoes in maybe Hawaii or Iceland.
Amazing. Okay, so it's really good to know what the moon is made of, but we're also trying to find water on the moon. Why is this particularly interesting for the moon?
Right, so water is one of our major questions throughout the solar system, and often a lot of our science in the solar system is based on trying to find the water. So for example, for Mars, for some of the other planets and their moons, because we associate water with life. Now, for the moon, for a very long time, we thought that it was pretty much bone dry. However, we have seen from some of our satellite data that that's possibly not the case. We do see some evidence for water molecules. And I want to reiterate, we're not looking at oceans, lakes, even puddles. This is probably going to be just ice mixed with the soil. So it would be hard to get at, but we do see evidence for it. And actually, some of those early experiments from Apollo, we didn't see water in our samples. However, they were really, really smart about things back then, right? So we preserved some of our samples because they're like, oh, technology is going to develop. Let's keep some pristine samples so we can reanalyze them later. And that has already started happening just recently. So that's really exciting. And we have been able to identify some evidence for water in those samples now with our better techniques. So the reasons that we are interested for the moon are twofold. We want to look at resources for our future astronauts. So it's, much easier if there's water there than exporting it from Earth. That's very expensive. Water's heavy, all these types of things. So if it's already there, our astronauts might be able to use it for, drinking, for running their farms, running a habitat. But water is also a component of fuel. So if we want to launch to other places in the solar system, it would be much easier to launch from the moon, which has lower gravity. So if there's already some sources for fuel there, that will be helpful. And then secondly, as I said, water, we equate that a little bit with life. Trying to understand the origins of water in our in the inner solar system especially is a really important question. There's quite a few theories about how we got so much water on Earth. So maybe finding it on the moon might be able to help us understand exactly how it's there. Like, was it there originally from the start of the solar system? Was it delivered by comets? That's a big theory. Or is it even being created right now from interactions with solar radiation?
Amazing. Yeah, I didn't realize that we could use water for so much in terms of colonization and creating habitats and so on. Very sci-fi, which means I love the idea so much. So you talked about the Apollo missions. One of the astronauts on Apollo 17 was a geologist. So if you could go to the moon and do a geology experiment, what would you choose to do?
Yes, that is right. There was one astronaut, Jack Schmitt, who was a geologist on the moon, and he was really integral in finding some of the samples that we have today, including some really cool things called volcanic beads that were identified to have water in them recently. So that's one of those really cool connections there. And all astronauts get trained in geology actually before they go to the moon, so that they have these kind of ideas and have some ideas about what to look for. But yes, so what I would like to do on the moon, I think would probably be related to seismology. I would like to do some more seismic experiments. Apollo did put some seismometers down, and we have a lot of plans actually to make a larger lunar seismic network. So when we think about seismology, it's mostly earthquakes on Earth, right? But what's really cool about that is that seismic waves can go through the interior of the Earth, so we can figure out the structure. So we would like to try to do this better on the moon so that we can get a really good understanding of what its internal structure is like. We don't have a really complete picture of that right now. So it would be really helpful if we could have more seismometers around the moon in different locations as well, and maybe a large asteroid hitting it so we can get some good seismic waves going through as well.
I've seen two pictures of the moon. You've got the side you actually see and then the dark side. What do we know about the differences between these two sides, and why do they even exist?
Okay, so this is a really interesting thing about the moon, right? It's tidally locked. So as you said, that means we only ever see one side. It wobbles a little bit, so we can see some little extra bits, but we can never see the far side, not the dark side. It does get light on it. When we see a new moon, that's daytime on the far side of the moon, actually. So the differences between the two sides are really interesting and really intriguing. We didn't know what the far side looked like until the Apollo missions, until we really got into space back 70-ish years ago or so. So for all of human history, we've only seen one side of the moon. And that's pretty cool that it's a recent discovery. But Anyway, so when you look at the moon at night, we see these big, smooth, dark patches and the bright bits. The far side is mostly craters. So it's mostly the brighter bits, or maybe a little grayer, and you don't have as much of the mare, which are those dark areas. And it's a real mystery as to why this is the case. We also, from our gravity measurements, think that it's a bit thicker on the far side. So there's many questions about why we have this dichotomy. And one of the ideas is that we see more of the cratering on the back because it's kind of acting to help protect us a bit. So the moon acts as a really good record for all the cratering history that Earth would have also seen. But we don't have the same type of erosion, so it gets preserved. So we can actually figure out some of Earth's history by looking at the moon as well. So now, because that side is always facing away from the Earth, it's kind of, and hopefully shielding us a little bit. We think that might be part of why we see so much more cratering on that backside. And there's a really large crater. If you are able to see, let's see, if you are able to look at a model of the moon, I don't know if you can see it very well in here, but it kind of is flattish on this side. And it's not a very great sphere all the way around. And now this was actually a huge crater. This is called the South Pole Aitken Basin. And we think that basically a huge impact happened. And one theory is that that may be why we have so much volcanic material on the side we can see, is that that kind of broke up the moon a little bit and created this part of this dichotomy, at least.
Wow, that's really cool. But speaking of what you get up to if you're on the moon, how much would you love to drive the moon rover?
That would be really fun. I might be a little worried about, going too fast and like taking a crater rim, but would definitely love to drive around on the moon.
Me too.
And in the same spirit of things, it's now time for my random question. So Alan Shepard on Apollo 14 played golf on the moon. If you could play a sport on the moon, what would you play?
Well, usually I like hiking and swimming, which I guess I'd be hiking around looking for samples, but swimming probably not going to work very well. So maybe I just wanted to set up some badminton with my fellow astronauts, blow off some steam, that sort of thing. It'll be fun.
What about you, Fox?
I like badminton and squash and dodgeball, that sort of thing. So I'm not sure how well dodgeball work because it'd be very easy to dodge the ball. And squash, you kind of already need to build a room for it. So I'd probably join you in the badminton, to be honest.
You can just imagine dodging a ball and it just going off into space forever.
What about you, Dan?
Well, I don't know why you're all choosing games that would make your life much harder. I would just play like a game of chess.
That sounds good. I think I'd join you on badminton. We were talking about this darts. How would darts be played in space? it would just because there's no air resistance.
And you can just like aim with your eyes and just let the dart go, and it would just.
That's true. You'd have much less gravity to contend with, so you wouldn't have to worry about it arcing down as much.
Javelin.
Maybe your aim would be better in a way.
Javelin.
Back to the as amusing as that was, back to the actual physics. What future missions are planned for the moon, and what experiments are they planning to do?
Well, there's a ton of planned missions right now for the moon. It's a hot place to go at the moment. But NASA has combined with commercial partners, and they're aiming to put at least 2 missions every other year on the moon. So that's really exciting. But otherwise, they're doing lots of different experiments. There's lots of questions that we have about the moon. Some of these things that they're looking into are trying to investigate water, kind of like I mentioned earlier, but also looking into lava tubes, which are really cool, and possible shelters for future astronauts. Artemis missions are planning to put people back on the moon by the end of this decade. Hopefully we'll be able to see a new human lunar landing in our lifetimes. Quite a few things that are going to hopefully look into some of the volcanics that I mentioned, including the mission that I'm on called Lunar Vise, and that's going to go to a really cool a silicic volcano. So these are more explosive volcanoes that you might think of, and we didn't really think these would be on the moon. So it's really exciting that we kind of have identified one from space, and now we can go land on it and see what exactly that might mean for the lunar geologic evolution.
Could you explain more about what a lava tube is?
Yes, so a lava tube is kind of the shell of a lava flow. So if you picture, a volcanic eruption and you have the lava flowing down, the exterior is going to cool down faster when it's exposed to air, and the middle just kind of keeps going. And if there's not a continuous input, then it leaves behind this hollow shell, and that's a lava tube. And you can find these on Earth. You can go hike through them and stuff like that. So on the moon, we have found evidence for lava tubes as well. And the idea is that if we can find these and there's a thick enough rock shell, that might be able to help if there's some kind of really hazardous event happening, like a big asteroid swarm or meteorite impacts, or maybe even a lot of radiation. Maybe we could have our astronauts kind of hide under this natural barrier to help protect them.
That is very interesting. Thank you.
Yeah.
Thank you so much for being on Physics Chat and talking all about the moon. It's been so interesting hearing about all the moon missions, and hopefully we'll get to see the next lunar landing. Let us know in the comments section, if you could play a sport on the moon, what would you play and why? We would love to hear from you, so keep writing. On the next part, we will have Katherine talking about comets, so stay tuned. But from everyone at Field of View, we hope you have a great day and goodbye. Bye.
Bye.
Bye. The moon would definitely be melted if it was cheese.
Right, so that will be part 1, and then...
So smooth. Well done.